This is video I10. And I asked you to try your hand at this problem last time. And so if we're looking for the intersection of these two values, we're looking for the x where they hit each other. Okay, we're looking for when this y is equal to that y then. And so the way in which I would set this up, there are multiple ways to do this, but I would say when is this y value equal to that y value? And since we're trying to apply Newton's method, which is a way to find zeros, well, I can rewrite this function as a new one by subtracting the 1. Okay, so here is the function. This would be the y. Okay, and Newton's method goes like this. Okay, we need a point, an x0, comma y0. And we're told to use an x0 of 1, and then the y sub 0 would be what we get when we plug a 1 in right here. So I have 1 cubed minus 1 minus 1, so negative 1. And then, here's our point, we need a slope. To find the slope, I need the derivative of this function, so y prime equals 3x squared minus 1. But I want the slope at that point that we're going to start at. So really what I want is y prime of 1, which is 3 minus 1, or 2. And so I have a point and a slope, and that's what's required for Newton's method. And let's box this up. So here's my information about x sub 0. X sub 1 will then be the x we started with. Now, don't forget that this is subtraction here. It's easy to mistake that and put a plus there. If you ever need to, don't forget this Newton's method comes from point slope form. And so you can always write out point slope form, plug in a 0 for the y, and an x sub 1 for the x, and just rewrite it. So you don't really have to memorize it. But anyway, so then I have the y value on top, the derivative at that point on the bottom, and so I get 1 plus a half, or 3 halves. So in theory, this is a better approximation for the x-intercept for this curve than x equals 1. But we were told to use 2 iterations, and so I have to repeat the process using this as the x again. And so x1, comma y1. 3 halves, comma. Okay, and then, of course, you have to do a little bit of work here. I did it already. You guys know how to do that. The y value I came up with was, I put in decimal form. Okay, and then we need to find the slope at this x value. So y prime of 3 halves. And I did that too. Don't forget, you just plug it in right there. And so here's the information I need to find my second iteration of Newton's method. So I have the x I'm starting at, the y I'm starting at, the slope at that point, which is approximately 1.3478, dot, 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 goes on forever, or 31 over 23. Okay, I think the only other thing I wanted to do is talk about maybe, or you know what we should do with this is, let's go ahead and see how close this is to the x value. And so I'll go ahead and enter the 2 functions. So I have x cubed minus x, whoops, and then y equals 1, just do a standard zoom. And I'll calculate the intersection of the 2. And it tells me 1.324. Notice how close that was just with 2 iterations again. Okay, so one question should come up. Because when I said this is in theory closer than our first guess, maybe sometimes Newton's method doesn't work. So I'll draw a picture of a case where Newton's method would fail. This is actually, I have trouble drawing this graph well, so I'll do my best. So let's say that you have a graph that looks something like that. Okay, and here's the x-axis. And you say, okay, I'm going to find this 0 by taking that as my first point right there, so x sub 0. And what you do is you find the tangent line, you find its 0, and then notice that it drops down way down here. Well, it shouldn't discourage you too much, so find the tangent line here for a second iteration, and we get back to the starting point again. So there would be this infinite loop. And so clearly there are some cases in which Newton's method doesn't work. Here's another idea. Let's say we have some simple function like this, and you go to great efforts to find, Newton's method to approximate that 0, but for whatever reason you needed the opposite 0 over here. Okay, and maybe a third way. Maybe there isn't a root there. Maybe there is a hole. So for whatever reason, maybe you have some sort of a discontinuity there. So there are lots of reasons why Newton's method might not work, but I think you should now be able to do the review problems 17 through 23.